sawn out the 10:1 ratio template for the hammer strut. I will machine the hammer strut from spring steel. I will machine the outer contour, then I will clamp it up in the lathe and machine the round end on it.
The switching thing remains the same way it always has. It's just tapping the sensor. The home button. Yeah, I was curious about that. I guess since earlier this week, I've also realized that
Okay, this is the finished template. I screwed the template down to my template base, put 3 screws in it and also 2 dowel pins. I will be machining the strut from this piece of 1mm chrome nickel spring steel. To hold it for machining, I will glue it to this sacrificial piece of brass with crazy glue. I clean both parts with acetone. Now I put some crazy glue on it. Put your part on it and drop a piece of steel on it to flatten everything out. Hey, yesterday I tried to make the strut. I glued the spring steel with crazy glue onto a piece of brass, sacrificial piece. The crazy glue I had is not suitable for metal, so it didn't help. The part flew off when I was almost through it. Now I glued the stock material on with 2-part epoxy, fast setting epoxy. So I placed the sacrificial stock with the spring steel glued on it in the vise on a pair of pellets. I put a 0.8mm carbide ball end mill in it, which will be used to drill the holes in the struts, and I will do a row of pieces. I will do maybe 4 or 5 in a row. And first I will drill all the holes and then I will contour them all out. Okay, I drilled out 4 of the holes. I'm going back to my first one and I'm changing over to a end mill. The ball end mills work pretty good for drilling in hard material. If you have a spindle that does pretty high RPM, I'm running this one on 12,000 RPM. And I will change you over. Okay, now you're looking up on the template table. With the template and the stylus of the machine, which controls the movement of the spindle, sits right in the hole that I drilled into the template. This is the position I used to drill the holes. Now I'm pulling the stylus out and drop the 10mm bearing that I run over it down so it touches the template and follows it. I'm using a 1mm end mill, a 10mm bearing or follower, and a reduction of 10:1, so I will reduce the outer contour of this template by factor 10 and we'll get a workpiece with the right dimensions. I'm going up and I'm going to enter the cut in this position so I don't have to plunge with the end mill in the material. And I'm just following the contour with the bearing. Well, I made one pass around and I'm exiting the cut. Then I have warmed my table and I do the same thing again. There went the part. Okay, so the two-part epoxy didn't hold. Hand finishing now. Okay, we're at the bench. I have 3 of the struts here. This is how they look when they have been machined out of a flat piece of spring steel. Just for reference, they are 0.9mm thick and about 18mm long. These two are like they came out of the sheet, and this one is already rounded over at the end. The end has a round stem of 0.9mm diameter. And how I did this, I will show you right. Tiny grinding wise. With a big Allen key, and I take one of the struts. The end that has to be rounded over gets put in the vise vertically, like this. I'll bring the camera in a bit closer. I'll bring the strut in like this, and to adjust it so it stands perfectly rectangular to the vise, I put a gauge block on top of the vise and press, can you see this? and I press the part against the gauge block and tighten the vise. This is what I set up on the template table. I just screwed a 9mm bushing to my template plate and use a 20mm follower as I'm running a 2mm ball end mill or ball nose end mill. Just touched off with the end mill around the part, and now I'm going to round it over. So I had to do some handworking on these struts, but now they are finished. They have the correct contour, they have the right thickness, they are made of spring steel, so they should hold up, and they have the right diameter hole here, and the pin-like end here has the right diameter also. It's 0.87 millimeters, and it should be 0.9 minus 0.08 millimeters. So I'm fine. The surface on the milled surface didn't get perfect because the 1mm carbide end mill I was using was in a pretty bad shape. Maybe I will do these again, but for now they're okay. I can at least use them when I test assemble everything. So that's it. Thank you for watching.